Problem 2, combustion analysis. You're going to do a combustion analysis on your own, but first I'll give you some hints to complete this problem. It says, a complete combustion of a 1.505 gram sample of thiophene is combusted and then it produces carbon dioxide, water, and sulfur dioxide. Let's write the combustion reaction out. So it starts with thiophene. And they tell us that they used 1.505 grams of that. And then they also tell us it's composed of carbon, hydrogen, and sulfur, so we could also write that down if we wanted. So it's combusted. What does it react with? Oxygen, O2. And it produces three things: carbon dioxide, and they tell us that is 3.149 grams that was collected, plus water, and they collected 0.645 grams of that, plus sulfur dioxide. And then they collected 1.146 grams. The molecular weight of thiophene is given as 172.2 grams per mole. What is the molecular formula? So we have to figure out how many carbons, how many hydrogens, and how many sulfurs there are in thiophene. What is the first thing you should do? Find the mass of carbon, hydrogen, and sulfur in the sample. Okay, so for carbon, what sample gives you carbon? The carbon dioxide. But this is of carbon dioxide. You want to figure out the mass of just carbon. So you're going to do some unit conversions to do that. All right, now for, let's say, hydrogen. Where is the hydrogen coming from? From water. 0.645 grams of H2O. Okay, but this is of H2O. You need to find the mass of just hydrogen. And then the third one is sulfur. Where's sulfur coming from? It's coming from sulfur dioxide. But this again is purely sulfur dioxide. You need to figure out the mass of just sulfur. How much sulfur is in that amount? Okay, so that is the first thing that you're going to do. Okay, once you do that, go on to the next slide. Step 2, it says determine the mass percentage of carbon, hydrogen, and sulfur in the sample. So you need to do that. Once you find the mass percentage, then you're going to assume you have 100 grams, and you're going to solve for the empirical formula. And lastly, let's review molecular and empirical. Molecular, if you have the molecular formula, what does that tell you? It tells you the number of atoms in a molecule. What does the empirical formula tell you? It tells you the simplest whole number ratio. So if you have a molecular formula of P4O10, what would the empirical formula be? Well, you can reduce it. If you divide everything by 2, you'll get the smallest whole number ratio, P2O5. Now for water, what would the empirical formula of water be? Well, you can't divide it anymore, so it's going to be H2O. So notice with water that it is both the molecular formula and empirical formula. Sometimes you can have that being the same. What about N2O4? What would the empirical formula be? Well, you can divide everything by 2, so it would be NO2. How about decane, which would be C10H22? You can divide everything by 2, so C5H11. Okay, and then we have this big molecule. What would the empirical formula of that be? Well, you could divide everything by 3. C2H9O. Okay, and then the last one, C5H12O, what could you divide, or what would the empirical formula be? You can't divide anymore, so it will be simply C5H12O. So notice also with this one that it is both the molecular and empirical formula. This concludes the end of chapter 3. If you have questions on anything, make sure you write them down and ask me during class time.